So organic chemistry is, of course, all about carbon. The carbons go just hook right together. With a compound like this, the bonds all rotate, and they're called hydrocarbons because they're typically covered with hydrogens. And this would be hexane, which would be perhaps a component of gasoline. If you take a compound like this and put one oxygen on it as a hydroxyl, it becomes an alcohol. So this would be hexanol. If you take this same compound and cover it with oxygens, it becomes a carbohydrate. So this one has 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So there's 6 carbons and 6 oxygens. The oxygens are in the form of a hydroxyl group. The common carbohydrate in our world is glucose. Glucose is a 6-carbon sugar. It's very common. They say that 30% of the biomass on the planet Earth is glucose. So we'll see how that's possible. Glucose forms a ring structure, and we want to look at that right here. The ring is formed between 1, 2, 3, 4, 5, 6. Is formed between this oxygen and this oxygen. So the oxygen makes a linking compound within the glucose molecule and makes it into a ring. The structure of glucose is a very complex three-dimensional image. The best representation of it, the easiest representation for us is probably this one. Let's take a quick look at it. We've got carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. So notice that the oxygen is at a corner. Notice that the oxygen makes a nice trigonal bond like we expect. These bonds don't rotate, so that this structure is pretty well set. We got 1, 2, 3, 4, 5, 6. Notice that the 5 carbon doesn't have any oxygen on it whatsoever. Let's take a look at the carbon number 4. We have the OH pointing down. If the OH was pointing up, then that's fine, but it's not glucose anymore. And then similarly, the OH on number 3, the way this is oriented, is up, and the OH on number 2 is down. The hydroxyl group on the 1 carbon is up in this drawing, but it could be down also. So this is glucose, but there's 2 versions of it, and one of them is with the hydroxyl group up, and one of them is with the hydroxyl group down. The way this one is drawn, the hydroxyl group is up, which is the beta form. The difference between the beta glucose and the alpha glucose, so the alpha glucose is here and the beta glucose is here. The difference between the two is really rather staggering. And the reason being is that the glucose forms polymers with itself. The polymers are formed as a connection between the number 1 carbon and the number 4 carbon. So it's like the 1 carbon hooks to the 4 carbon, and then the 1 carbon hooks to the 4 carbon, and the 1 carbon hooks to the 4 carbon, and they make polymers. And that's the bulk of glucose is found in these polymers. And I want to bring these models in and take a look at them. So the alpha-1,4 forms a bond, and notice that the bond is a V-shaped bond with oxygen, like we expect. And the glucose molecules with the alpha structure can just line up one glucose after another, and that's all good. To move forward with this image, I want an even bigger simplification of the structures. Let's take a look at this guy. This is the alpha structure. We have on the 4', we have a down-pointing hydroxyl. That's characteristic of glucose. And then the alpha on the 1' is pointing down also. So when we make our bond, we simply put the 1' prime to the 4 prime, the 1 prime to the 4 prime, and then we use these little oxygen guys to stimulate the oxygen bond. Notice that the oxygen is in a position to make the nice triangular bond it likes to make, or the nice trigonal structure. And so this is the alpha 1,4 bond. Let's look at the beta structure. This is glucose, so the 4 prime has a downward facing hydroxyl group, but the 1 prime is facing up. So we say, well, let's hook these together, and we quickly see that if we're going to put a regular bond on this, the alternating groups have to be turned over. So we end up with two very different structures. The structure with the alpha 1,4 is called starch, and starch is a very common energy storage material, especially for plants. It's also an energy storage material for animals. Starch is kind of right at the center of metabolism for all organisms on the planet. And the beta 1,4 is very different. The beta 1,4 is structural. It's called cellulose. It's structural, and things are made out of cellulose. Things referring to wood and paper and cotton. And the fiber in plants, the structure of plants tends to be cellulose. The fiber in the food that we eat is cellulose. Cellulose is to a large extent not digestible, and that's not, of course, entirely true, but it's a very different structure. When you look out at our world on the planet Earth, you are looking at the beta 1,4 linkage of the glucose molecule.